Hello everyone, just wanted to make a quick video detailing my home generator setup that I just finished installing. We live in the Houston area, and over the last couple of years we've dealt with various power outages and issues. Hurricane Harvey flooded our house, and so we needed generators during that time. Then shortly after that, a year or two after that, we dealt with rolling brownouts in our area during the summer as the heat level just got too hot for the grid to handle, and so they started shutting down parts of the grid. And then this last winter was probably the most dangerous. We experienced about a year ago in February 2021, we experienced a freeze that came across Texas, an unusual freeze that for Texas we were not ready for, and so we lost power for a few days just due to the grid not being able to handle the extra pull that was going on with everybody running their heaters and electricity and staying in their homes. And then in our particular situation, we not only lost power, but that ended up leading to our pipes freezing and busting in our attic. So our house flooded a second time within about 4 or 5 years, and had to redo some rooms. So at that point we said, you know what, enough is enough. We're getting a generator. We're tired of going through this situation and relying on other people. So I started looking into generators a lot and into the market and seeing what people were doing. And I wanted to make this video because I felt like the setup that we have here is a little unique and a little different than anything I've seen on the market. This is the largest portable generator that I could find, and I decided to stay portable so that I had the option of taking it and helping other family members at other houses nearby instead of doing a permanently installed option. So that's why we went portable, but I also felt like I could get pretty much the same output out of this portable one as I could out of a permanently installed one if I do it the right way. So I'm just going to quickly walk you through what I have here and show you why my situation is unique, and hopefully this will help somebody out there who's in a similar situation. Now, I have a 2-story house. It's larger than the average house. It's pretty much close to 4,000 square feet, 2 air conditioning units. And so it requires a little more power than the average, 1-story house. So just to kind of give you an idea. So I ended up going with the Generac GP17500E. And if you see here, it is 26,000 starting watts and 17.5 running watts. And the max output on this generator, which was what really drew me to it, was 72 amps. It's a current of 72 amps, max output current. So that was really enticing to me because once I did the calculations, I figured I might could power my whole house on that. And sure enough, it ends up being perfect for it. So I'll give you a quick look through of the generator. The generator itself, the other thing that really drew me to it is I have a 50 amp here, 240 volt 50 amp. I have a 240 volt 30 amp. I have a 120 volt 30 amp, another 120 volt 30 amp, and 4 120 volt receptacles, just standard duplexes here. This one is a GFCI. Also have this where you can charge your battery as the generator is on. I thought that was kind of cool. And I have breakers for every single receptacle here. So it's a pretty cool setup that they've built here. I found out that these are made for construction sites, which is also why it has the hook here to where at the end of the day, the construction crew can put it on a hook and get it up on a crane off the ground so nobody will steal it. So that's why it has the hook there. It has a 12 volt battery, unlike other generators that is a pull start. It is a battery start. So that is a single point of failure. So I made sure that I have a battery tender that will be on it at all times. And this is the one that I ended up choosing, which will keep the battery healthy at all times. So the other thing I have here is this generator. It's unique because it is bonded at the generator, which was something I really had to research in depth and really make sure I do properly, because I am interested in following code here in this particular install, and I am interested in doing things proper so that it's safe, because we do have a ton of power here. So there is bonding that is happening inside the generator here, and you can't really see it here, but it's happening behind the case here where all the receptacles are. And then we have our actual grounding wire that comes here. And so what I've done is I have the generator set up in my backyard in the event of emergency. So I have a grounding wire that runs over here, and I have permanently installed a grounding rod in the grass right here. Just simple. So the grounding wire will stay connected to the generator, and I just bring it out anytime I need it. And I just put that lug on right there and make that connection. So with that being said, the grounding and neutral are bonded inside the generator, meaning that we don't have to worry about grounding into the earth after this point. You ground at the first point of disconnect, you bond them together at the first point of disconnect. This is technically what's called a self-derived system. So this will be bonded here, and then the ground will just follow the cables back to the inlets and then to the boxes inside my garage. But there's no further grounding that needs to happen. Now what that does, as you'll see in a second, is it does require me to switch the neutrals when we're doing the manual transfer switch. And that's very important, because if I don't switch the neutrals and I only switch the two hots or the two phases, whatever you want to call them, of the 240 volt receptacle, the problem is there could be voltage on the neutral in certain situations, and then that would send voltage, you know, as everybody says, you could send voltage back down the line and hurt somebody who's trying to help get the power back running in your area. So don't want to do that. So anyways, so that's how I have the grounding and the neutral set up. I've got a few toys here. I've got a light that will turn on if I ever have to pull this out at night. It's just a work light that I have strapped on here. It charges USB, and then it's battery powered. It's got an internal battery. I'm not sure if you can see this. Let's see. I also have, this tells me the health of the battery. So right now it's 71% and 12.4 volts, just so I can always watch it. And when I trickle charge it in the garage, earlier it was up to 89%, but I've been running this generator almost all day right now doing some tests. And then this will tell me the RPM, and the goal is to hit it right around 3,600 RPM. So this is our RPM meter. The connections that I have now, this is where it gets unique, and this is where I haven't seen anybody else do it. So me and my electrician, we worked and put our heads together to come up with this particular system. What we're doing here is what I see most people do is they'll just use the 50 amp receptacle, which I believe is, if my math is correct, 12,000, would give you about 12,000 watts. But you're still leaving the other 5,500 watts aside. And I see people do that all the time on generators. So I said, what is a way that I can try to take use of all the wattage, like use all the wattage, maximize my usage just to have it if needed. So what you'll see here is we came up with a system where we're going to use the 50 and we're going to use the 30 amp 240 volt receptacle to power the house. So in essence, we have we'll have up to 80 amps here because it's a 50 and 30. Now the generator maxes out at 72, so we do have to be watchful of that. But as you'll see, we don't get anywhere near hitting that. So anyways, and then I just have an extra cable here, 120 volt cable, just as an extension cord. I'm running a fan out here to push away the carbon monoxide and stuff like that for right now. But anyways, it's just a homemade cable I made just in case we ever need it for anything. So yeah, so that's pretty much it. So those cables there, here's our 50 amp, and the 50 amp is going to plug in a minute. I'll show you it up and running. The 50 amp is going to plug in here, and this is my 30, and my 30 is going to plug into here. And these two cables are going to run along my back porch, and I have these two inlet boxes that we have brought to the back porch. I have a 50 amp inlet and a 30 amp inlet, and we just simply patch those cables into there. From there, we have the wire running through conduit, and it's EMT conduit, and it's going to run down the whole side of the house. quite a long run, but that's my situation. So it's gonna run down the side of the house. It's gonna run up the wall here, and we're gonna run into the house at this point. And this is actually the garage on the other side of this wall, and that's where we'll see the panels in just a second. So the other side of the wall here are the panels. And basically what we have here is we have 5 panels that we installed. The 2 in the middle are the existing panels for the house. My house already had 2 panels, so that's what also made my system, or me, be able to really justify this system without having to do a ton of modifications to the house itself, to the branch panels. But basically what we have here is we have the 2 existing branch panels from the original install of the house. We have a junction box here where both the utility power and the generator power come into the house. And then we have Polaris in there that splits it to different destinations. And then this light gray box and this light gray panel are the transfer switches. And so you'll see in a minute, I'll actually go into where I actually show it running, and it'll transfer it. And then down here, we actually have meters that are metering everything that's going on. So we have wattage, amperage here, current, wattage, voltage, kilowatt or wattage hours, and power factor, and then frequency. So this is just a way that I can monitor what is going on in this particular panel. So basically the power comes into here, then the utility power, then it's going to come into this panel here. And if I open it, you'll see this is a transfer switch from Reliance, and this is the utility side that comes in, and this is the generator side that comes in. And whichever one is on, this mechanism does not allow you to have both of them on at the same time, but it does allow you to have both of them off. But when you have whichever one you have switched on here, it will feed to the main lugs out here. Those lugs of switch A will then send over to here to panel A, and then it will power this entire panel right here, which powers about 60-70% of my house, okay? And that will be connected to the 50 amp inlet that you saw in the backyard. Then this other transfer switch is transfer switch B, same exact box, we just have smaller breakers. This is a 100 amp input breaker or utility breaker. This is a 30 amp generator breaker, since back there the second cable is only 30 amp. Whichever one is switched here will then send over to panel B, which this is my smaller panel here. So basically these 2 panels, when I'm on utility power, these 2 panels are totally isolated from each other. There's a split up there of the utility power, and it splits to both panels. And then when we're on generator power, we get our power from here and here, and once again, they're totally isolated to each other. So these panels are not interconnected in any form or fashion. And then these meters right here are measuring this panel. And these analog meters, I just thought it was cool to have them on there. It's just a second way to monitor your wattage, but these are wattage meters. They'll monitor that panel, and then these wattage meters will monitor this panel. So that's basically how the system works. What I'll do real quick is I'll actually show it to you up and running. So here we go. Okay, so now I'm gonna simulate a power outage. So with my house, I actually have a disconnect outside that disconnects from the utility power from the power company. So my power comes from the meter into here, and then it goes into inside, and then we did the split inside. So I'm gonna simulate a power outage. So I'm gonna turn this off, so we've lost power. We'll go back here, and we will look in the garage here, and we will see we have no power, okay? All right, we have no power to anything. So now what we're gonna do is we're gonna open up this transfer switch and get ready for generator power. And I'll wait till a second to show you how to switch that over. Let's go back to the generator. I'm going to open up the fuel valve here to get fuel into the system. Double check a couple things. All that looks good. Full choke. Fire it up. Here we go. You won't be able to hear me at this point, so all I'm going to do is show you how I connect the cables, and I'll go back to the garage. Okay, now you guys will be able to hear me better. I've got the generator sending power now to these two transfer switches. So we should be able to turn on this switch right here. So the utility is still technically on, but we've killed the utility of the house. But when we hit this switch, it forces the utility off there. And now we have power coming in. 124 volts. 60 hertz, no amps because we don't have any branch circuits on right now. So all looks good there. Okay, we're gonna come on, and now that was the 50 amp side. So now we're gonna do the 30 amp side of the generator. So switch B, we're gonna turn it on. Okay, same thing, same voltage, same frequency, all looks good. Okay, so now we are off of utility and on generator, but the house is not working yet. So now all we need to do is go into the branch circuits and one by one start flipping them on. So here we go. Yeah, just flip it on. It'll turn on in a second when I get to it. There it goes. All right, we got garage lights. Let's see here. All right, that one can go on. We're gonna kick this on. So just going through all the bedrooms here. Okay. All right. This is panel B, which is the 30 amp side. I just switched everything on the 50 amp side. This is the 30 amp side. Okay. And boom. So in theory, we should have power to the whole house. And if we look, this is the 30 amp side. Now we're starting to get a draw on amperage. Right now I mainly have lights and stuff like that on. I could turn on my AC in just a second and we'll see. So without air conditioning being on, my 50 amp side is pulling 4 amps, still 120 volts, frequency's holding good. Yeah, everything looks good. So that's solid. And on the 30 amp side, voltage is solid, frequency solid, amperage is plenty because remember we got 30 amps to work with. So let me pause the video real quick. I'm going to turn on the air conditioners and I'll get back with you on the pole that we're getting there. Okay, cool. Just wanted to pause real quick, get the house up to full load so I could show you. Okay, so this is the 50 amp side that's coming in from the generator, and which is manual transfer switch A, and right now I have the air conditioning and pretty much every light on in the house, and right now I'm pulling at most 26 amps, or 3,000 watts on this side, 2,000 on that side, so 6,000 total. So I'm basically at about half of my capacity on this 50 amp receptacle, or this 50 amp side of the generator, if you want to call it. So that's great. My analog meters here are showing at roughly 50% as well. So I've got everything running in my house. The only thing I really don't have running right now is like a microwave, oven, stove, any heating elements. And we have a lot of gas appliances, so I'm not too concerned about that. Okay, this is the 30 amp side of the generator, the 30 amp receptacle. And that has a air conditioning unit on it as well upstairs, a 2-ton air conditioning unit. So we see here voltage is good. Current is 6 on this side, 6.7 on that side. And yeah, wattage is 700 and something here. It's 780 there. So yeah, I mean, we're not getting anywhere near close to tapping out that side of the generator. So basically right now we're running at 25, let's see, we're running at a little over 30 amps total on the entire generator, if my math is correct. And the wattage is, let's see, this would be about 6,000, and this would be almost 2,000. We have 1,500, so we're probably at 7,500 watts. So we're not even really hitting half the generator power. So we got tons of headroom here, which is great. It makes me feel comfortable and confident that I'm not going to overwork the generator, and everything works great inside. So the generator is still running at 3,600 RPM. So. All right, so let's go see, make sure we got power inside the house. And there we go. We have power, everything is on, nice and cold in here right now. Air conditioning's working. Upstairs, downstairs, everything is working. So, that's my setup, guys. Hope you enjoy it. Hope it helps others out there, because I know it was quite a journey. It was almost a year journey for me to figure out this out, to figure everything out, to source all the parts. That took a long time due to everything being back ordered, to source the generator and to find the right electrician to help. By the way, if you're interested in doing this and you are in the greater Houston area, I highly recommend calling EI Services. I'll put it in the link in the description below. EI Services, they came and did the actual install. Also, Miguel from EI helped me think through this and basically design the system. We put our heads together, because I do have some working knowledge of electricity, so we put our heads together, came up with this system, really happy with it. Now I just gotta re-sheetrock these walls from where we cut into it, and I'll be ready for the next storm. So God bless, hope this helps. Take care.